Hello everyone, in this video we will discuss about the alarm system in CoDeSys. To design ladder diagram for the alarm system in CoDeSys. To develop a PLC ladder diagram to construct an alarm system which operates as follows. If one input is on, nothing happens. If any two inputs are on, a red light goes on. If any three inputs are on, an alarm sirens sound. The fire department is notified. According to this given problem, so we can take four inputs. So that is up to four inputs we can take, and we can check for all these four cases by designing the ladder diagram. There are four cases. Correspondingly, we can take four inputs. Now for the first case, if one input is on, nothing happens. Input one is on, nothing is happening. According to this only, we have to design the ladder diagram. So for second case, 1, 3 are on, two inputs are on, red light goes on. In the third case, 1, 3, 4 are on, a siren sounds. And the fourth case, 1, 2, 3, 4 all are on, the fire department gets notification. So now we'll see how to design the ladder diagram for this particular application. So let's say rung 1, rung 2 and rung 3. We can design the ladder diagram for this particular application using three rungs. So first rung we can take combinations of inputs, that is 1 2, 1 3, 1 4 and 2 3, 2 4, 3 4. So all these should be 1 2 should be in series, and 1 2 series combination is in parallel with 1 3 and so on. Next, for rung 2 we have to take three combinations: 1 2 3, 1 2 4, 1 3 4, 2 3 4. The contacts should be in series, so 1 2 3 series combination should be in parallel with 1 2 4 and so on. And the last case, that is for rung 3, all 1 2 3 4 four inputs are in series. So let's go to CoDeSys and let's start the design for this particular application, that is ladder design for this particular application. So once we design the ladder diagram, this application works. Go to file, new ladder opens. We'll start with the first rung, two contacts in series, and those series combinations should be in parallel and so on. That is 1 2, 1 3, 1 4, 2 3, 2 4 and 3 4. Let's see. So take first contact here, say this as A1. Take second one A2. So now parallel contacts for 1 3 series with 1 3 series should be parallel with 1 2 and 1 4 and so on. So name this as A3. Here, then choose contact. You have to name this as A1. So 1 2 1 3 is over. Next is 1 4. Take again parallel contact. Name this as A4. Click on the contact, then choose contact. Click on A4 first, then click on contact. So then we'll get a A1 should be in the first place. So 1 4 1 3 1 2 1 3 1 4 is over. Next is 2 3 2 4 3 4. Similarly, continue for all the other input combinations. This should be A3, A2, again parallel contact, A4, next A2. For 2 3 2 4 is over. Next is 3 4. A3. First one is over. Give the output as red light. Okay. So next, so for second run, you have to take 1 2 3 1 2 4 1 3 4 3 2 3 4. Network after. Click on network after. Give it as A1, A2, A3. So A1 2 3 is over. Next is 1 2 4. Just give A4. Click on A4 contact and then choose one more contact. Name this as 8. Next, click on A2. Choose one more contact. Here it will be A1. Next, again one more parallel combination of 1 3 4. So take this as A4. Then it is A3. Then it is A1. So 1 2 3 1 2 4 1 3 4 is over. Next 2 3 4. In this as A4, A3, A2, 2 3 4. 1 2 3 1 2 4 1 3 4 and 2 3 4 is over. That is second run completed. Alarm, alarm, sirens. So next again take network after. Consider 1 2 3 4 inputs contacts should be in series. That is A1, A2, A3, again give the output. So this is fire department 5. So now the design is over. Now we have to build the alarm system. Project build. There are no errors and no warnings. Now we have to run the design. Click on simulation mode. Click on login. It is logged into the ladder design. Now we have to check for the ladder working. So here we have to consider first case, that is if one input is on, nothing happens. So let's say I'll turn on. We have to check for all the A1 to A4 input combinations. Let's check it. First case, for the first case, if one input is on, nothing happens. Let's say I'll turn on A1. See, nothing happening. So no any outputs are on. So next we have to consider A2. I'll turn off A1 and I'll turn on A2. So see here, nothing is happening again. So next I have to turn on A3. Let's say I'll turn on A3 and turn off A2. So nothing is happening. Next A4. So nothing is happening. So it confirms that first case is, that is if one input is on, nothing happening. Okay. So next for second case, that is if any two inputs are on, a red light goes on. So this should be on if two inputs are on. Let's start with first case, that is 1 2. Turn on 1 2 A1 A2. Okay. So once I run this, a red light should turn on. So we can see red light turns on. So red light turned on. Now we have to check it for 1 3. Turn off A2, we'll turn on A3. 1 3. So again still red light is on. We'll check it for 1 4. Again red light is on. Next 2 3. So 2 3 are on. So A4 should be off. So 2 3, all the 2 3 switches are on, but these two are off. Now red light is on. So that is 2 3 for any two, that is 2 3 inputs are on, red light is on. So next is for 2 4. 2 4. So it means wherever you have connected A2 switch in any things, if it is turned on at a time, all the switches which are connected to at the all the three rungs turns on simultaneously. Next 3 4. Turn off this, turn on A3. So you can see red light turned, still it is on. So it confirms that the second case, that is if any two inputs are on, a red light goes on. It is confirmed. Next is for third case, that is if any three inputs are on, an alarm sound will take 1 to A1 2 3. A1 A2 A3. You can see alarm sirens turned on 1 2 3. Next is for 1 2 4. Again alarm sirens sound. Okay, next 1 3 4. Again alarm sirens is on. Okay, next 2 3 4. So 2 3 4, again alarm sirens is on. So now consider the fourth case. Third case is over. Now fourth case, if all are on, the fire department is notified. So let's say we turn on A1 also. 2 3 4 are already on. So fire department notification is on. So this confirms the ladder design for alarm system in a fire department. So this is a fire alarm system in CoDeSys. Thank you for watching.